Yes, you
Yeah,
can you hear me
yeah, I
too?
can hear you. How are you?
Fine, thanks. And you?
Yeah, I'm fine, thank you. Okay. Okay, so basically we are starting the new training program on for today's session. It is about the landscape analysis, how we can easily do landscape connectivity. So these type of things I will try to explain step by step. I hope you can easily get all of things. Okay, so let's go start. Let me share my screen. Okay, can you see my screen?
Yes.
Okay, so let's go. So yeah, so let's go. Okay, so basically this is the program. For today's I discuss about that landscape connectivity analysis, such as landscape fragmentation or modeling pathways using remote sensing. Okay, and I will try to use here different types of programming language such as R programming or Python. Okay, and we can easily get this type of analysis for the landscape. So first of all, I discuss about some theoretical part, then move to the practical session. So first of all, landscape connectivity analysis. So basically this analysis help you to evaluate how well different landscape pairs are connected. We can easily get this type of idea when you do for the landscape connectivity. We can easily evaluate how well different landscape passes are connected, then important for biodiversity conservation, then wildlife corridors, and also ecosystem health. We can easily get the idea about that. And also we use different types of things such as graph theory, then least cost path analysis, and circuit theory model. Okay, so this type of model we try to develop using programming language so we can easily use it. Okay, and we also discuss about the quantification and indicators of landscape fragmentation, such as measures how landscape are broken into smaller and isolated passes. We also measured this type of things. And also common indicators such as pass density, then edge density, then largest pass index, then fractal dimension. So this type of indicator how you can easily compute, we also discuss about that. And also impact, such as what is the impact on the habitat loss or decrease the biodiversity or ecological imbalance. So this type of impact we also discuss about that. And we also use different types of model, such as modeling the pathway and movement the potential within a landscape, such as multiple least cost path for multiple destination, then least cost corridor analysis we also discuss, then least cost path considering the land use and water bodies, and least cost path with elevation penalty. So this type of thing was discussed practically. Then Monte Carlo simulation for uncertainty in the least cost path, and least cost path for animal movement. So this type of things all of I will try to show you that step by step for practical session. So we'll also discuss about this type of topic. And pass and edge analysis indices, such as pass analysis. So basically pass analysis is identifies the discrete habitat or unit and their distribution. And also edge analysis, basically it examines the transition zone between different land cover types. And also key indicators such as mean pass size or perimeter area ratio or edge density or core area matrix. So this type of things to discuss about that. So landscape metrics, basically in this time we talk about that, it indicating about the quantitative tool to analyze the spatial pattern and can be categorical into pass level metrics such as shape, complexity or isolation. So this type of things. Then class level metrics such as fragmentation or aggregation, and also landscape level metrics or diversity connectivity we also discuss, and different types of tool also used in here. So fragstats, it's one kind of tool. We also use here the Google Earth engine, or also QGIS, also ArcGIS, or R programming language. We are also use this type of analysis. Okay, so let's go. First of all, we discuss the landscape, how we can easily practically these type of things. Suppose okay, let me open okay, Suppose in this case, I will try to show you this example using R programming, how we can easily use, and I also send you this type of practice code. So this code you also try to adapt for your own study area, okay, and also check the result, okay. So here I already write this type of code. I also send you this type of code. Then further this type of code you also try to adapt for your own study area and then check the result, okay. So first of all, here you can see the first line. Okay, so first of all, do you have any idea about that R programming or not? Such as basic case.
Yes.
Okay, then it's also great. Okay, it's also great. So then you can easily catch all of those easily. So let's go start from here. So we simply install some packages such as elevator package. So basically this package give you the DEM data. We can easily download the DEM for any world, for any region using this package elevator. Okay, this is one kind of package. Then raster, it handle the satellite imagery or TIP imagery or raster based data. Then G distance, so this it's one kind of library, so it help you to calculate the distance. Then SP, basically it's handle the different types of vector data, or RGDAL, it also work with the satellite imagery or raster based imagery you handle. So just we simply install all of package together. Just click on here. So now it start the installing. Just a minute. Okay, so again installing, you can download, you can see all of package. Okay, so simply all of package elevator, then raster, then G distance, then SP, then RGDAL. So this type of package we simply install it. Okay, after that simply import. Suppose I import the library elevator. Okay, it also imported. Then import the library raster, then import the library G distance, then import the library SP, and also import the library RGDAL. So we simply import all of necessary library which we need. Okay, so after that we need to define the box, bounding box. Basically it's your study area. Okay, suppose which area you want to do, just simply put here the basically latitude longitude value, okay, for this right, or x mean y mean, and also x max y max. Simply import your own value and then it your study area. Okay, just I run it. So I simply put these things. So just this is our study area, we simply select and now convert to a special object. So in this case we simply call a library sf. So basically this sf convert to a special object. Okay, special object, basically a special object, basically it must take the latitude longitude value, okay, or coordinate value. So just call the sf, this library we simply import, and now we are just use a function, basically this function st as sf. So this function help you to convert a special object. So then we simply put here the data frame and we define here, you can see the x min and y min and x max and y max. So this value we simply define in here and also put here the coordinate x min and y min, and CRS mainly coordinate reference system, just mention in here 4326 for this study area, coordinate reference system. So now just I run it. So now it convert as a special object. So let's go. So now we try to download the DEM data. Okay, suppose I want to download the DEM data. So for downloading the DEM data, we already install a package. It's called the elevator. So basically from this package, we can easily download the DEM data for any region in the world. We can easily find out these things from here. Okay, so simply we already import this DEM data in here. Okay, so then further okay, just call the get elevate raster. So it's one kind of function. So I simply call function get elevate raster. So this function download the DEM data. Okay, and I need the dem data for my boundary box. So basically this is my boundary box. Okay, just I call it, and basically then we put here that in here this jet 10 meter. So then we just run the, we get the data 10 meter pixel resolution. We just click to the run. So now you can see it downloading, assessing the raster elevation. We find out in here. Okay, and elevation units are meter. Okay, meter. And now I want to display this dem data. So for that, simply use the plot function and call the dem, and use here the main, just simply put the title. So it's a title. So when you set any title, then you simply put at the main and then just put this title. So now we find out this type of dem data. Suppose it's a dem data, we find out in here. Forward study area, we download the dem data. Okay, and this is the you can see this type of, it's a low elevation, it's a high elevation. We find out this is the legend about that. So it's a dem data, we can download and also work with that. But if you want, you can also download the dem data for Google Earth Engine. So you can easily download the dem data because you already know about the Google Earth Engine. So from the Google Earth Engine, you can easily download the GeoTIFF file format dem data. So further, you can also use it for in RStudio also. Okay, I'll show you that process also. Okay, we already know about that, how we can easily download the dem data. So for downloading the dem data, simply search the data set. We already know. Simply search here NASA SRTM. So this is the dem data I want to download. So just import, and further you can easily download this dem data from here also. And this data you can also use in RStudio. Okay, so this is the dem data, basically elevation. Okay, 30-meter resolution. Just import. Okay, I think networking issue, just a minute. Okay, it's now work. So I simply search here NASA SRTM. Okay, let me down input from here. I think some networking issue. Okay, so you find out that train data, just click on here. Different types of train data, we can easily find, or you can see. Yeah, we try to use it. NASA dem. Right. So this is the dem data, 30-meter resolution. So this data we can also use in RStudio, and then further we also try to calculate the cost path analysis. So let's go, just a copy and then paste here, and then give a variable name, suppose dem. Let me just add a layer. So you find out this type of dem for the whole world. Okay, whole world dem data. And elevation. Okay, let me select the band name. dot select elevation. Okay, we find out this type of things, dim data. So now I want to download the dim data for a specific place. Suppose this is my study area, or you can also put here or stress the data, then also get the more better resolution. Suppose if I just stressing 98% and then apply. So this is the dim data. We find out look like that. Okay, basically this type is indicating about the high. So I have to download this dim data. Suppose this is my study area. I want to download for this. This is my study area. So I need this dim data for this boundary. So I simply choose my boundary. Okay, you can see it's a geometry. So now this dim data I need for this geometry. So for that, just use here the dot clip function, clip with geometry, and run the code. So now we can get the data only for this boundary, and this data I want to download. Okay, this data I want to download, and further I want to make the analysis using the R, using this for the cost path analysis or different types of work we can do. So let's go try to do it, download, and we can also add the color. Suppose if you want, just add here, suppose low elevation, so this type of blue color, then get it, then show this type of green color, or then use this type of yellow color, and high elevation show as this type of red color. Just I choose and then apply. So now it will be set with our, so we can easily identify where is the high elevation, where is the low elevation. You can easily get this idea. So now this dim data I want to download, and further I want to work with R for different types of analysis. So let's go. So for that, just export image to drive. So it will be saved in your drive, and just I try to export image to drive. So this is our argument. We are just simply fill up all our argument one by one. So first one is for image. Okay, just write here image. So image basically this dim we have only for my study area, and further description I put here description, suppose dim data. And further region I just put here region, other is the optional region. I put its region is the geometry. Then scale is the resolution 30 meter. Okay, just run the code. So now I can either download the dim data from here. Okay, just click on the task tab and then click to the dim, run it, just run. So now it will be downloaded. So further you can also use it. Okay, so it also working. So in the meantime we'll discuss about another part. So suppose in this time we get this type of dim, and now I want to compute the slope. Okay, suppose compute the slope and cost surface based on the slope. Okay, so for that just use a function, train function you apply in here, train, and then just call the dim. Okay, this is the dim data. I want to calculate the slope, so just put here the slope, and I also select the unit, slope unit I choose degree. Okay, basically you already know about the two types of slope we can calculate, percentage unit and also degree unit. So I choose the unit is the degree, and further just run it. Okay, so now it also work, and further we need to normalize the cost surface. Okay, so for that I just take a variable cost surface and then just call the slope. Okay, just run it. So now we just plot the cost surface slope. So now you find out, you can see this is the slope we find out in here. Okay, this is the slope, this thing is a slope. Okay, so this is the way we can calculate get the dim data from directly. We can download that directly using the elevator, Or if you want, you can also download the DEM data from the Google Earth engine. So you can see it also downloading. So further we can also use it in the R, and then we calculate the slope, and then we also calculate the cost path analysis we also do from here. Okay, so now we convert the raster to transition matrix. Okay, so basically this slope, it's a raster, so these things we need to calculate into transition matrix. So for that, just use a function transition, and 1 divided by cost surface, this is the cost surface, and transition function we calculate the mean or average, and direction we put here in the 8. So just convert, then apply the geo correction. So now I want to choose a point, suppose latitude longitude value for my study area. Suppose this is my start point and this is my end point. So between this point we can just simply check which one is the cost path analysis. Between these 2 point we do it. So for doing this thing, just apply here the start and then end, then I plot, just plot. You can see this is the start, so this is the start point. Okay, and this is the end point, we simply put the end point. So now between this 2 point we calculate the LCP. LCP means that least cost path. Okay, least cost path we compute. So for that we are just take a variable shortest path. Okay, shortest path, it's one kind of like function. Just call the shortest path and apply the tr. Mainly it is stored our geo correction. Okay, tr. Okay, which we can calculate the slope. So it's as stored the geo correction slope. Okay, tr, and then apply the start. This is it is stored the start point, and also end, it is stored the end point. Okay, and output we just special lines. So now if I just run the code, so now it compute the LCP. Okay, LCP means that least cost path. Okay, based on the DEM. Okay, so basically we can calculate the least cost path using different factor. So further we'll also discuss about that land use land cover factor or water body factor. So in this factor we consider the DEM data. Okay, from the DEM we calculate the slope, and based on the slope we just calculate the LCP, meaning least cost path. Okay, so let's go, we try to plot and also just plot the line. So you find out, you can see this is the least cost path. Okay, between this 2 point, from this blue point to red point. Okay, we find out this is the least cost path we find out in here. So further I want to calculate the cost distance. Suppose from here to from here, what is the distance we calculate. So just for that apply a function cost distance tr. It stored the slope, basically stored the slope geo correction data, start point and end point. Okay, these things we already calculated. So just run it and also print the total cost. So we find out this is the total cost from this point to from this point. So it's one kind of analysis. So it's also called the least cost path using DEM data. Okay, so you can easily download the DEM data from using the elevator, as well as if you want you can also download the DEM data from here. Okay, using the Google Earth engine. Further we are just simply define our point, suppose from this point to from this point, based on the DEM where we find out the least cost path. Okay, these things we can easily analyze using R. It also possible to use the Python or also Google Earth engine. So further another series we also discuss about that. Okay, do you have any question regarding this topic? You can ask me please. Any question for the least cost path based on DEM data?
At the moment, no.
Okay, so I also send you this type of code also. You also try to adapt this type of code for your own study area. Further, if you face any problem, you can simply knock me. I also guide you, no problem. Okay, it also
Okay,
working.
perfect.
It also working. So after downloading this thing, I'll also try to import this data in the RStudio and also show you that how we can easily work with that. It also working. Just a minute. Okay, let's continue. Okay, we talk about this type of things. LCP, how we can easily calculate least cost path. Okay, so now multiple destination. So in this time we find out only for the two destination or 2 point. Okay, but when we have multiple destination, then how we can easily do? And also calculate the least cost corridor analysis or least cost considering the land use and water bodies, least cost path with elevation penalty, or this type of simulation, how we can easily calculate, and least cost path for animal movement. So basically for the animal movement, when you calculate the least cost path, so then we also need some data. Basically we need the animal tracking data. Okay, it also possible to compute. Okay, let's go try to discuss about the multiple destination, how we can easily calculate for least cost path. Okay, let me open. Okay, so for this same process, so this is another code. Same process, we need to import the library gdistance. Okay, just import. Then also import the library for raster. Then also import the library for sp. Okay, and then we just simply bounding box. Okay, simply put the bounding box x min y min. Okay, or x max y max. Just put, and then convert. Same process. Just simply convert a special object. Okay, so these things just simply convert into a special object. A special object means that it has latitude and longitude value. Okay, so basically coordinate, we also define the georeference, mainly coordinate reference system, CRS value. So just I simply use the sf function, sf library. From the sf library we simply call this function st as sf, and then we make a data frame this type of value. Okay, basically x min y min and x max y max value, and then we set it as a x min and y min. X min y min, basically it's a coordinate. Okay, we also define the crs value for that. Okay, just run it and also define download the dem. So basically get 11 raster. So this, it help you to download the data for the dem data for this box, boundary box, which I define in here, x min y min value. So just run it and also plot the dem. So it's downloading the raster elevation data. Okay, done. We also get same plot, okay, same study area is it. So then we compute the slope as a cost surface. So just simply compute the slope. For the computing the slope, just call the train and then input the dem data, and then I want to calculate the slope, so option degree. And now we just simply use this equation, avoid the division by 0. Okay, so we just avoid the division by 0. So for that, simply use this equation. So compute the slope and also do it. So now create the transition matrix. Okay, calculate, and we define the start. So you can see this is the start point. Okay, and but we special point, suppose I have some multiple in location. So multiple in location, so this is one location, basically latitude longitude, this is the another latitude longitude, this is the another latitude longitude. So I have total 3 coordinate or 3 location. So now from this 3 location, which one is least cost path I want to identify. Okay, so it start point only one. So as you can see, start point only for the one coordinate. Okay, but in points I have multiple location. So this one location, this 2 is another location, and this is another location, basically coordinate. So now I want to calculate which point is least cost path between the three location. Okay, between these three location, which point is least cost path. I want to analyze these things. So let's go, we try to do it. So just I define the start and end, and now we just just plot the dem. Okay, so now here you can see I just use a function. Okay, basically for loop we are also using here. So in this time we are just input the for loop in point coordinate. We just call the coordinate, mainly all of coordinate we can store it in here, and calculate the lcp and also take a variable lcp and use the function shortest path between the for this tr. Basically this tr is stored at the slope. Okay, slope start and end points. In this time we call all of end point, all end point. So here you can see three location, this end points is stored at all of location. Okay, and output a special lines we consider, and line we just create a lines about that. So now just run it. So we find out, and also just okay, so here you can see we find out this is the least cost path between it start from here and multiple location I have. So between this location, which point is more least cost path, we can easily find out from here. So this is the multiple least cost path analysis we also use. For the multiple, just we need to input the more, location. Okay, but start from the one. So this is our start, but between this all of point, which one is the LCP, mainly least cost path based on the dem. So we are just simply find out this point is the LCP, mainly least cost dem. We can easily find out from here. So now we are just compute the accumulate the cost surface, just and also normalize and also plot. So you can easily find out. Okay, okay, just a minute. So this is the corridor. So this is another part, sorry. So this is the corridor analysis. Okay, just a minute. So just I run the code again. So this is the plot, and here we include all of those, and this is the point, start point, and this is the end point. So this is the start point, this is the end point. So between these 2 points we find out that multiple, we have the multiple location, but from the multiple location we just find out which one is the most LCP. Okay, so multiple location, it's very useful for it. There are a lot of application such as wood life corridor analysis or emergency response planning or road network optimization. So this type of work we are also use the LCP for the multiple least cost path. It also helpful. Okay, so then we talk about that least cost corridor analysis. Okay, so least cost corridor analysis, so basically it's helpful for migration corridor mapping and landscape connectivity analysis or infrastructure planning, mainly highway or pipeline. So these types also use it. So let's go, we discuss about that for how we can easily do for that. uh, yeah, least corridor analysis. So for the least corridor analysis, we need to compute the accumulated cost surface. Okay, so when you calculate the least cost corridor analysis, then you must need to compute the cost surface, accumulated cost surface, you must need to calculate. Okay, so for that just I use a function. This is the function, and this tr it is stored the dem data or slope data, and this is my start point. So now we calculate the cost accumulation or cost accumulated, because in this case we talk about the corridor analysis. Okay, so this is the main things about that. When you calculate the corridor analysis, then we need that compute the accumulated. So just I run it, and also cost corridor. Okay, just simply addition with int. Okay, just int, and further just normalize the corridor cost. So for the normalized corridor cost, just simply divide it with this max values for the cost corridor. Okay, so now we just find out, just plot. So just cost corridor, we simply plot it, and you also put here the list cost corridor. This is the title. Okay, and this is the color about that, and we put this point. So this is the point, and this is the another point. Okay, so this is, we find out this type of things for the corridor analysis for the 2-point plot for the corridor. Okay, so as well as we also do for different types of things, suppose list cost path considering the land use and land water bodies. Okay, so this is another condition considering. So in this case you need the land use land cover imagery. Suppose you can use the Google Earth engine and make the land use land cover classification for your study area, and further download the geotip file format. So this tip file format you can easily import in the RStudio. Okay, in this case this is my land use land cover for the 2010 in Freeton. So here I already make it. So how I can get it? So basically you can simply write here get directory, get wd. So if I just run it, so here you can see this is my directory. Okay, so this is my folder. This folder is connecting with the Google Earth engine. Oh, sorry, it's connecting with the my local storage or local file. So this is my files, you can see. Okay, so in this time all of file I can easily access because my RStudio is connecting with this folder. Okay, so now I simply just stored this file, my land use land cover file, in this folder. Okay, this folder I just stored this file. So now I can easily access. So just I take a variable LULC and call the raster. Basically this function help you to read and write with the tip imagery. So just use our LULC Freeton 2000. This is the file name. This is the file name. I simply put in here and run it. Okay, so now after assign the cost value, suppose higher for forest, lower for road. Okay, so we simply assign some cost value. So higher for forest, lower for roads. So we can also change it. It totally depends on you. So in this time we can see water is the high cost. Okay, urban is medium cost, road is the low cost we consider for the land use land cover classes. For the water body we consider it's a high cost, urban is the medium cost, road is the low cost we consider. Okay, and further we simply assign the value in here. Okay, suppose 115222331. Okay, this is the class level. Suppose water body, urban and road, this is the class level. So just run it, and also we combine the cost layer. Okay, so in this time we can see 70% and 30% we consider cost surface multiply with 70%, and LULC cost we consider the 30%. So total 100%. We combine the cost. Okay, it show the one error. What is the error? Error in the compute raster. Okay, let me run the code again. Okay, it show the different resolution. Okay, okay, so in this case, yeah, so it's another problem. We have to use the same resolution. So basically in this case, this land use land cover, it used for Landsat. Basically it used for Sentinel. Okay, so their resolution is not mass, so that's why you find out this type of problem. It show the different resolution. Okay, so you try to use the same resolution when you do this type of work. Suppose for the DEM data is 30-meter resolution, so you also try to use the land use land cover also 30-meter. Okay, so in this case sentinel 2 basically it's a 10-meter or 12-meter, so that's why we face this type of problem. They are the different resolution. Okay, so that's why it's show this type of problem. Okay, error in the compare raster. Basically in this case with simply connecting the DEM data with land use land cover. Okay, so you can see when you combine, so cost surface it's come from DEM data, and LULC cost it come from our map, LULC map. Okay, so that's why this cost surface basically DEM resolution and LULC resolution you must keep the same. Suppose 30 meter DEM data, land use land cover also 30 meter, then we find out that result. Otherwise it show this type of problem. Okay, different resolution. Okay, so when you do this you also try to use the same, then I hope it also work, and other rest of the code is the same. Okay, for the analysis. Okay, this is LCP considering land use land cover. So this is the land use land cover, and just on it. So in this case we can see it not working because our resolution is not match for the land use land cover resolution, and DEM data resolution is not match, so that's why it not work. But when you work with for your own study area, you try to keep the same resolution for the land use land cover and also DEM data, then you also find out that result based on the land use land cover and also water body or DEM data. Okay, okay, do you have any question? You can ask me.
Instead of construct a matrix, I can upload my own data frame with points
Yes,
in a list with longitude and latitude for the start points and the end points, right?
yes. So basically when you modify,
Mhm.
so I also send you this type of code, you try to modify. So in this case here you can see here I put the matrix. So basically this is my own bounding box. Okay, but when you work with for your own bounding, so here you can get this type of value. Suppose I want to work with this geometry. Okay, so here you can see when I just use here the geometry, it show me this. Suppose this is my study area, this is my study area, this is my study area, I want to work this boundary. So when I draw a geometry, it give me some value. Just click on here, you can see you get this type of value. Okay, so from here you can get the x mean. Okay, so this is the x mean, then we also find out that y mean. Okay, so this value further simply copy from here and then use in your RStudio. Okay, then we can easily find out our bounding box. Okay, or if you want you can also just okay, you can also just try to download the DEM data from here. Just you can see here you already download the DEM data for our study area. So this DEM data you can also use in your study. Okay, you can see this is the TIFF format DEM data. Suppose I want to use it, so how I can use it? So simply download it from here. So just I will show you the practical example. Just download it. Okay, downloading. Okay, done. Yes, it's downloading. So this DEM data further we can also use after downloading our own study area DEM data. As well as suppose for this study area, you also make the land use land cover classification for this study area. So you also download this land use land cover classification tip format. So further this two tip format you can also use in here in the R, and also make the analysis, cost path analysis or LCP analysis based on the land use land cover and also DEM. Okay.
Okay.
Yeah, it's downloading. So in this case it show the problem because here you can see this is my another study area. Okay, but I download the DEM data for the another boundary. Okay, and this is the another land use land cover. So that's why it create the problem. Okay, when you just keep the same
Yes. Yes.
study area or same DEM or same area for land use land cover, then you can easily work with that land use land cover based on this DEM. It also work, no problem.
Okay. Yes.
Yeah. Okay, downloaded. So after downloading, what can I do? Just copy your file. Okay, it already downloaded. Just go to the file. This file simply copy. just you can see the copy and move to your directory. Okay, so how I can check the directory? I already checked the directory. You can see this is my directory. Okay, this is my directory. So just I simply find out the folder and store the data which I downloaded. So just open. Okay, this is the folder. So this folder I simply paste this item which I downloaded. So here you can see it where is it? Okay, let me again. So this is the tip. Just simply just I copy and now I just paste here. Okay, it will be able. So this is the dem data. So now I can easily access the dem data in here. So for that, just suppose I take a variable in here, dem. Okay, and you can see this is the dem data. Okay, so just I call raster and call this dem data. So just write the file name dem data dot tip. So now run it. So you can see it also work. So just I plot. So you can say I can get the dem for my study area. Okay, so this dem I downloaded from my study area. So now suppose I want to work with this study area. For suppose some point I want to find out the least cost path for my study area. So for that, simply take a point. Suppose just I click on here and I take the point. Suppose this is my first point. Suppose this is my start point. This is my one point. I take the another point. Just I take the new geometry and I just this is my another point. So now between these 2 points, I want to find out the least cost path analysis based on the dem. So how I can do it? So very easy. Just we try to import the latitude longitude value. So I'll show you that. Okay, I'll show you in here. Just I want to show this code in here. Just I import the dem which I downloaded. So just I take a variable, suppose dem, and then call the raster, and now call this dem data. So here at the dem data we find out this is the dem data. So just I write the name dem data dot tip. Okay, just I run and also run it. So you can easily find out this is the dem. Okay, so now I compute the slope. So let's we try to compute the slope and also normalize the cost surface and also plot the slope. Okay, so this is the slope. We can see this is the slope. Okay, so now convert the raster transition matrix, then apply the geo correlation. So now we simply put here the value, our two value, basically longitude and latitude value. So we can easily also get, you can see I already imported this 2 point. You can see this is the longitude, this is the latitude. Simply copy. Okay, just copy and use here. Just I change it. Okay, this is my start point. Just I change it. And this is the end point. I also change the end point. So you can easily get the end point from here. Just I copy. So in this case, we just take only for the 2 location. Further, you also take the multiple location. Same process. Just take copy. And also just paste here. Okay. So now just define here the start and end. And also just plot the dem. Okay, it working. Okay, it's plotting. So you can see it show the red alert. It means that it now it's working. Okay, it's still working. It take the huge time. Just a minute. Let me stop.
Yes,
LCP.
it takes a lot.
Yeah. Okay, this is the total cost distance find out in here, but it not visualize in here. Okay, just a minute, run the code again. Okay, let me just decrease the sum number. I take only for the two digit, only for the two digit. Okay, so now run the code. So start int and plot the temp. Yeah, so now we find out the temp, and now this is a start point, blue color. You can see this is start point, it appeared in here, and this is my end
You
point.
aren't share the screenshot.
Okay, can you see the screen?
No.
Why? Just a minute. Oh, okay, so now it's visible.
Yes, now yes.
Okay, okay. So you can see, find out this is the point. So this is my start point, this is my end point. So this point I already selected from here. I get the data from the Google Earth Engine. Simply we start point, end point. So now I want to identify between these 2 points what is the LCP. Okay, I want to calculate the least cost path distance. We calculate. So this thing we can easily find out. You can see we are just simply put the start and end point. This is my start point, this is my end point. So now between these 2 points, based on the DEM data, mainly slope, we calculate the LCP. Okay, so let's go. We just import the data in here. DEM data also work with. So just compute the LCP now using the shortest path. Just simply calculate. Okay, infinite vertex name. Okay, it shows one problem. Invalid vertex name. This is the point, also this point. Okay, but cost distance, okay, some problem. So it show the error in the cost distance. Replacement has length 0. In addition, okay, some coordinates not found. Okay, I think. Okay. So here you can see this is the problem. This is my dem, but
It's
some
found.
points are not found in
Okay.
the dem data. So we simply change it the in
Okay.
point. Then I hope it also works. Just a minute. So we are just keep suppose a 92 or 92.5. Okay, 92.5 we try to keep, and then check whatever 92.5, 92.5, 92.5 0.05 we consider. Okay, so now let's check again. Start, this is the end, pull out the dem, this is the start point, and then this is the end point. Where is the end point? Okay, I put it 21.5. I just let me check the coordinate properly. Suppose I want to take this point. Suppose this is my in point. Okay, so this is the point. So now check the coordinate for the in point. So this one. Just I copy. And paste. So now let's check again. Okay, so now I find out in here, you can see. Okay, so now let's check LCP. Ironin as graph versus 2. Inflates vertex name. Okay, so is there any problem in the data set for the dem or what? It show the Iron as iGraph. Okay, let me run the code again. Suppose I just import all of package. Then in this case, we download the dem data from Google Earth Engine, store it in this file. Just plot. So this is our dem data. We calculate the slope and also normalize, then plot the cost surface. Okay, this is the cost surface. Then convert raster transition matrix, apply the geo correction. Just apply the geo correction. Working. So it's working for the transition matrix. Okay, it's a lot of time. Okay, so if you just make a bounding box and then check what happened. Suppose in this case we create this type of things. So from here I just simply copy this x mean and y mean. Just take only for the 2 digit x mean y mean. Then take the x max y max, x max y max. Okay, just copy and use it in here. Okay, so I also define this value, convert to a special object, just change the value. Okay, so now try to check run the code again. Okay, just I stop it. Take a lot of time. Just import elevator, raster. I just import all of library. I also define the extent. Okay, now we download the data. It's not it, just I comment it, it's not it. Okay, so it is a common problem for the timeout. Okay, so now let's go try to solve it. So for that, when you face this type of problem, timeout was so at a millisecond. So for that, you just use a function. When you face this type of problem, just use the options and set the time. Suppose time out equal. Suppose I put the 1000. Okay, so now run the code and also download the temp. Yeah, so now I hope it will work. Okay, it's working. Okay, you can see it's downloaded. Elevation units are in meter. Okay, so let's go plot. So you find out, you can see this type of dem. Okay, so I think this is the problem when you download the dem data from Google Earth Engine. Basically, in Google Earth Engine, all of them have already, all of imagery already done the different types of correction. Okay, geo correction, this type of correction already done. So then when I apply the correction again in the R, basically using this type of transition matrix or geo correction, then it not work, it create this type of problem. Okay, so that's why we download the dem data using our boundary. Okay, for our boundary from the elevator. Okay, elevator provide with the main dem data without correction from the elevator, we can download it. So we find out this type of dem. Okay, let's go try to calculate the slope and also normalize and also plot the cost surface, and now convert the raster into transition matrix. Okay, so now it's very quickly now work, you can see. Okay, and also apply the geo correction and define the start, define the end, again plot the start, so now compute the LCP. Okay, so now I think we face the problem for the coordinate. Just a minute. Okay, let me change. Suppose start point I consider suppose 22.9. Sorry, 92.17, then put it suppose 22.8. Okay, so this is the one point we select, and another point I want to choose, suppose 92.45. Twenty-two point seven. Okay, just I choose it. So now run the code. Okay, so we find out this is the point. So now between this point we try to calculate the LCP and also plot lines. Yeah, so now it finally find out in here. So you can see this is our least cost path. Yeah, so you can see between this point to between this point, so this is the least cost path distance. Okay, so basically it's a hilly study area or hilly region, so that's why it's ignore all of high slope area or high slope region, simply ignore. And then we can find out this is the least cost path from this point to from this point, we can find out in here. So this is the way you can also use and further calculate the total distance. So we find out this is the total cost distance in here. Okay, unit is the meter. from this point to from this point. Okay. Okay, do you have any question?
No, I think it's cool.
Okay.
It's good.
Okay. And further you can also export it. Suppose just save as the image or save as a PDF. Suppose save as the image, just click on here, and then you can simply put your format. Suppose JPG format, choose, and further where you save it. I want to save it. Suppose in the desktop. Just I choose the desktop, and then just save it. Okay. Just click to save. So now it will be saved as a photo. Okay, from this point to from this point you can find out. And this same procedure also apply when you work for multiple direction. We already discussed about that. So multiple direction, we need the multiple point. So between this point, which point is more close, or which point is the least cost path. Okay, so in this time we are just consider only for the dem, but if you want you can also consider the different types of landscape such as water body or vegetation. Suppose in this case you can see this is another example for that least cost path considering the land use and water bodies. Okay, so for that, suppose for this study area you also can make the land use land cover. Suppose you can easily make the land use land cover using R for this study area. Okay, this study area simply make the land use land cover and classified, suppose water body, build up, or vegetation, or any other classes. So these things just simply download as a GeoTIFF file format and also work with that. Just simply import the LULC TIFF format, and further we simply combine the water body, urban area or road or any other classes we just consider as the LULC cost. So in this case, so basically water we consider the high cost, urban is the medium cost, and road is the low cost. So simply we serial the level, and further we combine the cost layer. Suppose cost distance we take the 70% and LULC cost 30%, simply combine, and then we are just make this analysis, compute the LCP based on the land use land cover, also dem. Okay, so you also try to do this type of work for your study area. Further face any problem or any error, then you can also knock me. I also guide you for that, how we can easily get the solution. Okay. Okay, so after that, this is another example, least cost path with elevation penalty. So basically it's very useful for different types of work such as hiking, okay, or running. So different type purpose we also use this type of penalty. So for that, just we define the dem. Okay, dem mean values, dem we just consider dem minus dem mean values. So this is the one kind of equation, compute the elevation penalty. So when you compute the elevation penalty, just use this equation, dem minus minimum value of dem, okay, divided by maximum value of dem. Okay, you can see the max, mainly max values of dem, and minus you can see mean values of dem. Okay, so this is one kind of equation for when you compute the elevation penalty. Okay, just we compute the equation using the dem, just run it. Okay, then adjust the cost score, cost surface. So simply we already calculate the slope, just simply 1 plus elevation penalty, just simply use this formula, just run it and compute the LCP for penalty. Okay, just run it, shortest path, and further just plot the dem and also lines with LCP. So we find out this type of things you can see. Okay, same we find out in here, penalty LCP. So we can easily run this line or this road, we just follow and run, then there is no risk. Okay, because it's not much higher or it's not steep. Okay, there is not much high slope. Okay, based on the slope we just simply calculate the penalty elevation. Okay, so LCP with elevation penalty. So this is the equation, simply use, and then we can also compute about that. So now Monte Carlo simulation for uncertainty least cost path analysis. So for that we are just plot the dem. Okay, just set the set and plot the temp. It computing. So it generates the multiple LCP by randomly perturbing the cost surface. So in this time you can see it create the multiple line. Here you can see it come from here. You can see it. This is the another line. Okay, it also create the another line. So basically this Monte Carlo simulation for uncertainty in least cost, it generate the multiple LCP. It generate the multiple least cost path by randomly perturbing the cost surface. Okay, so this is the another way you can see, you find out the multiple. So if you zoom it, then it also get better idea. Just a minute, how I can zoom. So you can see it create this multiple. Yeah, it created some multiple LCP. Okay, so basically this is the way for least cost path. We can use the different types of factor and calculate the least cost path. Basically DEM data, land use land cover data, sometime for the only for the 2 point, sometime we calculate for multiple location. Okay, so this is the way to calculate LCP. Okay, so this is the example. Yeah, land cover data. Okay, so now we talk about this topic. Suppose how we can easily calculate the landscape analysis. Okay, using the land cover raster dataset. Suppose you can make the land use land cover classification for any satellite imagery, Landsat or land use land cover, or any classified, suppose water body, forest, build up, cropland or shrubland. So now we want to make the landscape analysis. So basically we can easily use the landscape analysis such as class level metrics. We can calculate class level metrics, as well as we can also calculate landscape level metrics. We can compute it, as well as we can also compute the patch density. Okay, also calculate the edge density, also calculate about that mean patch area. Okay, also calculate the landscape division index, also calculate this type of thing. So I also send you this type of note. You also try to follow, then also get better idea how it will be work. Just a minute. Okay, so let's go try to develop this type of things for the landscape analysis. So in this case, we simply install this type of package. Just simply install. Okay, just yes. And in this case you can see we import the raster, install the raster, then tra, then sf, then ggplot2, then landscape matrix. It's very important. So basically in our studio we are also using the landscape matrix to identify different types of landscape matrix such as fragmentation, edge density, patch density. We can easily work with the landscape matrix and also card. So this is another one. So you can see we also import this type of library, raster library. So basically it's handling the raster data, raster processing, then SF, mainly vector spatial data, ggplot2 for visualization, landscape matrix for the landscape matrix, and then curl is for downloading the file. We also use this type of package. Okay, it's working. Okay, done. Okay, done. So now just simply import all of library such as raster, then Clara, then SF, ggplot, then landscape matrix, then library curl. So now we can download the land cover data. Suppose we can easily download the ESA world cover data from directly. Okay, suppose you can simply visit the simply search here, or you can also make the land use land cover classification map for your study area, or some dataset is the ready-made dataset you can also find out in Google Earth Engine. So you can simply search here ESA world land cover data, you can see. Okay, ESA world land cover, so you can easily download the data. Suppose I simply click on here. So from here you can easily download the data from ESA world cover 10 meter 20, just that we can simply download from here directly, download from this site. Or if you have any you can easily use the different types of machine learning and use the Google Earth Engine to make the land use land cover classification and classify different types of classes. You can also use it, no problem. Or you can also download the data. Basically it also provide the world land cover data. We can easily download the data tiles by tiles, and further we can also use it in RStudio. Okay, so here you can see this is the one kind of data. So it's provide you the all of ready-made data set. Okay, and it's very high resolution. We find out the tree covered data, then shrubland, grassland, cropland, build up, barren land, snow, permanent water body versus wetland, mangroves, moss and lichen. So all of things we can easily get from this ready-made data set. So from here you can also download the data. You can see the download folder, just click on the download. So here you can see the different types of tiles. So ESA, so you can see basically it provides the tiles wise data. So you can see find out this type of tiles. It's loaded. Yeah, so you can see this is the tiles 1 2 3 4. So which tiles you need, so just suppose just click on here. Okay, I need the TIP image, so it's only for the PNG file format image. Download. So here you can see the data. Suppose I want to download this tiles, or you can see multiple tiles, you can also choose. Okay, so you can simply choose this multiple tiles. Suppose I choose this one, and then next. Okay, so you also need to log in and also registration with the login. So first time if you user, just simply register with that and so put all of information. Okay, and then login, also use this data. Okay, so this data you can easily download from here, and further you can also use it in the RStudio. Okay, just import this URL. Okay, you can see this is the dataset URL. Or if you have the data set land use land cover data in the in your local storage, suppose you can see in this time I already make the land use land cover classification map and store it in the in my directory. Okay, so just I take a variable land cover raster, and then I simply just import and also plot it. So you can see this is my land cover data. Okay, so this data I classified 0 1 2 3 4. Basically 0 is for build up, 1 is for settlement, or basically these different types of classes, forest. So this is the land use land cover map you also need to create for your own study area when you work with this code. So simply make this land use land cover classification map and also import in here, and then we calculate the class area for each land cover types. So for that, use the function lsm c land cover raster. Just run it and also print. So you find out this type of value for the class area. So you can say the class. So class 0, 1, 2, 3, 4. Okay, so different types of class area also find out in here. And you can see here what is the class area. So basically we find out class area. So class area, this metric calculate the total area occupied by each land cover classes. Okay, and higher class area for forest, in this time for we find out the forest, indicate the large continuous forest region. Okay, because you can see in this time we find out the forest is for 500 square kilometer. It means that forest large continuous region we find out, and low it's the urban area. You can see we find out for this time only for the 200 square kilometer. So urban area suggests that less urban expansion. Okay, and if the cropland has a high ca, if the cropland, in this time cropland is the 400, if the cropland has a high ca, mainly class area, it suggests that agriculture is dominant in the region. Okay, so this is the class level matrix. So how we can easily deal with that? So in this time, suppose I find out the forest is the 500 square kilometer, water is the 100. So in this time, if I find out the 500 square kilometer, it means that it indicates the large continuous forest region. Okay, and while I find out the ca is the lowest is the urban area, so it indicating about the less urban area or less urban expansion. Okay, and cropland is also not high. It means that agriculture is dominant in the region. Okay, it says that agriculture is not dominant because it's only for the 400. We find out the last forest area. So this is the class level matrix we can compute this way. And it interpretation, you can see if the forest have a low ca, they may indicate the deforestation. Okay, if I find out the low forest area, it means that this place have the deforestation. If the build up area have a high ca, it means that urban expansion is significant. Okay, so it's called the class level matrix, and we can easily calculate the class level matrix area using this way. So in this time for my reason, you can see for the c how much area, 1 is how much area, 2 is how much area, 3 is how much area, 4 is how much, we can calculate it. And how we can easily interpret this result this way. This way we can simply interpret the result. So then landscape level matrix we calculate. It called the NP, number of passes. So let's go. So after landscape matrix, you can see for the I take a variable landscape matrix and use this function and call the land cover raster. Okay, land cover raster basically stored my different land use land cover classes. So let's go try to run the code and also print this result. So we find out, you can see this value landscape value. We find out that this value. So what it means, you can check it from here. So it's called the landscape level matrix. So landscape level matrix number of passes. This measures the number of distinct passes for all land cover types. So in this case, for the all land cover types, I find out this is this value. Okay, 21,040 for all land cover types. It indicate about the measure the number of distinct passes for all land cover types. And high NP means that landscape is fragmented. Okay, so when I find out the high value, mainly when I find out the high number of passes, it means that landscape is fragmented. And low NP, low number of passes, that large continuous area exist. So you can say I find out this value, it means that this land is it's a high value, it's a large value, it indicating about that landscape is fragmented. Okay, but when I find out the low value, it means that we find out the large and continuous area exist on the landscape. Suppose you can see if I find out the NP value 250, it means that if NP is high, the landscape is highly fragmented, and it's meaning the habitats are broken into smaller passes. Okay, so if NP is high, the landscape is highly fragmented, and it's meaning the habitats are broken into smaller passes. And if the NP number of passes is low, it means that land cover types are more continuous. Okay, so this is the one value we can always find out here. So now patch density, so we calculate the patch density easily. So for that I just take a variable patch density and call this function LCM LPD and call the land use land cover. Okay, just run it and also print. So we find out this type of landscape patch density value. So now what is that? What is the meaning about this value? So basically patch density, what it means, basically patch density is the quantify the number of passes per unit area, and high patch density indicate the more fragmented landscape. Suppose if I find out the value 1.8 and high patch density, habitat fragmentation is increasing, and this is the bad for the biodiversity because species struggle to move between the patches. And low PD, basically it the largest continuous patches exist and which is beneficial for maintaining the ecosystem. Okay, so it's the interpretation. So we also interpretation this type of things is also helpful. And edge density, so we can also calculate the edge density. So let's go. Okay, just we try to plot it. Land cover raster and also plot. So now it's plotting land cover classification, and further we calculate the edge density. Okay, so for the edge density same, just we take a variable edge density and call the LSLED and land cover raster and then run it and also calculate the mean pass area and also print the edge density. So we find out this is the edge density value for my land use land cover. What is the mean about that? So basically edge density is the measure the total length of all passes edge per unit area, and high edge density means the more fragmentation, and while lower ED indicate the compact and less disturbed landscape. Okay, also you can see the interpretation about the edge density, you also check it. Also you can say mean pass area, we also calculate the mean pass area. So just simply print the mean pass area also. So we find out this is the mean pass area. So it indicating about that average size of passes in the landscape. Okay, and largest pass indicate the more connected habitat. So high MPA, mainly high mean pass area, it large continuous pass we find out good for ecosystem stability, and low MPA value it indicating the bad for biodiversity. As well as finally landscape division, we also measurement from here for the landscape division, and this type of result we can also download as a CSV file. Okay, so I also write the coding and see save the result as a CSV file. So class matrix CSV file, it will be saved as a CSV. So from this CSV we can easily get all of data and also download this type of land cover classification. We also download it from here. Okay, so let's go check the file. Okay, okay, so you can see this is the file, CSV file. We just view this file. Landscape, we find out the landscape value. Okay, from here, from the CSV value, or you can easily randomly we can calculate all of values one by one. Okay, landscape metric, patch density, all of this thing we can easily calculate from here. Okay, so this is the way to calculate and also interpret the landscape uh, analysis result when you work for your own study here. Just follow this interpretation and then you can easily get the better decision. Okay, for the is metrics, suppose class level metrics, landscape level metrics, patch density, or also edge density, okay, or mean patch area, landscape division, Okay, we can easily get the more better result. So also you can see final interpretation result, you can simply just follow it and also make your final interpretation result. Okay, so class area, number of passes, okay, pass density, edge density, mean density, landscape division index. Okay, then you also get the interpretation with your study area. Okay, okay, so, any question please?
No, I only need to apply in my study area
Yeah.
for face the errors or
Yes, okay.
for the down.
Okay, so
Mhm.
I will send you all of code and also send you this type of document. So you also try to follow and then try
Yeah.
to apply for your own study area. Further face any problem, then we also discuss about the problem solving class. No problem. Okay.
Yes, thank you.
Okay, so this is another is very important. So we also basically for our another topic. Let me check. After landscape connectivity, another topic is for network and node analysis. Is very important for betweenness space. Okay, so we also network how we can easily identify for the node or network analysis using the graph theory to understand the landscape connectivity. Okay, and link between the passes and helps the designing conservation strategies, migration corridors, so as well as a route movement pattern for environmental monitoring and also urban planning. Okay, as well as also landscape connectivity. Okay, we also discuss some topic, also have also rest of topic we also discuss further next class. And so graph theory based and least cost path analysis. Okay, basically this type of least cost path analysis we can also do using ArcGIS or QGIS or Google Earth Engine. It also possible to use, but R is very easy. Okay, R programming is very easy because we can easily get all of necessary library easily, and we can easily adapt this type of code. Just need to import your data, just need to import your boundary, just need to import your land use land cover data. Then we can easily use the same code and we can easily get the result very quickly than ArcMap or QGIS software. So ArcMap and QGIS software randomly we need to calculate. But in this case, if your code is ready, just you simply import your data and you can easily get the result. Landscape result, also least cost path result, anything we can easily get very quickly. Okay, then ArcMap or QGIS software. Okay, so let's go. Okay, let me open the code editor. And node or connectivity, discuss about that next class, how we can easily work with the node and connectivity. So now I talk about that how we can easily work with fragmentation. Okay, or pass density or edge density. So this same concept we can also apply the Google Earth Engine. Okay, this same concept we can also apply for the Google Earth Engine and also calculate the pass density and also calculate suppose different types of landscape metrics we can also calculate from here. So let me open my code from here.